Hello dear viewers, a very warm welcome to our channel. It's very good to have you here. In this video we are going to have a look at all you need to know about the connecting rod. The connecting rod is a very crucial component inside an internal combustion engine. You can think of the connecting rod as a very critical middleman. It's the engine's middleman. Think of it as a very critical link between the piston and the crankshaft. It will connect the crankshaft. It's a component that translates the reciprocatory motion of the piston to a rotary motion of the crankshaft, which ultimately powers your engine. Now, had there been no connecting rod, when power stroke happens, piston will move down inside the cylinder, but because the force is not being transferred to the crankshaft, then the engine or the car will go nowhere. The explosive force inside the cylinder will simply push the piston and it will get wasted. So this is a critical link between the piston and the crankshaft. This is the one that is going to transfer that immense power. Now, when you look at the anatomy of the connecting rod, it is a deceptively very simple looking, but very immense strength and precisely machined component. Well, when you look at the component, right here we have this small end. We call it the small end because compared to this, it is a smaller. This is the top hole that connects to the piston via wrist pin. This is the small end. This is where piston gets connected. Look at here, for example. There is a piston pin which is inserted right this way. Right, see, you see the piston pin. So this small end or the piston end is typically a solid eye, or it may have a bushing. And this is where the piston is inserted, and this is the connection between the connecting rod and the piston. So this small end, we call it the small end. Then that will be followed by the shank. This is the shank, or sometimes known as the beam. This is the body of the rod. It is designed for both strong and lightweight. Now its cross section is often an eye type. When you look at it like this, you see there is an eye. Right here there is an upper part, lower part, and then there is a middle part. So it has an eye configuration, or sometimes when you look at like this, it has an H configuration on some cases. So it is either eye or H-beam shape, which provides excellent strength to weight ratio, resistance to bending and buckling under load. This is a very much strong design. So you can see this is an I-beam type, for example. If you see every connecting rod, it has a similar shape. You see, this one is a little wider, the lower one is a little wider, and the middle is a little narrow, making it an I shape. There is an I shape that makes it very tough, very strong, and very rigid. Now, the I-beam is commonly used in most production cars, many performance engines, and excellent for a compressive load. It has a resistance to compressive load. And the H-beam type is often found in high performance and diesel engines, better at handling tensile and compressive loads without adding much weight, making them stronger for high horsepower. So this is how the shank is designed. Then we have the big end. Right here we have the big end. The big end is the larger bottom end that attached to the crankshaft. Now it will have a split end. If you remove this, there is a split half. This is the cap, and the connecting rod cap is there. It is split into two parts to allow fitting on the connecting rod. The connecting rod will fit onto the crankshaft like so, and then the connecting rod cap can be installed. And finally, we have the connecting rod cap. This is the removable half of the big end, and it is bolted to the connecting rod with high strength bolts. These are high strength bolts. Don't interchange them when replacing. These are high strength bolts. And then we have cap screws. So this is the big end rod cap. And finally, in between, we have bearings. Shell bearings of this kind will be inserted, one on the upper and one on the lower, so that it can have a riding surface on the crank pin of the crankshaft. Usually split shell type bearings are used, and this is very critical wear surface. When now friction is happening, this big end and the rod cap will not be wearing down, rather the bearing will wear out. So if this wears out, then you can replace it. So this is how it is constructed. Now, When we look at the science behind the construction of the connecting rod and some of the forces that it endures, connecting rod is one of the most highly stressed component in your engine, subjected to extreme and rapidly changing forces. For example, compressive stress is there. During the power stroke, when there is explosion inside the cylinder, piston is forcing this connecting rod at a massive power. So during the power strokes, the force of combustion can be thousands of pounds per square inch, trying to squeeze the connecting rod, trying to force it like so. And this is the single largest force that the connecting rod should handle. Then piston will have to go back again. When piston is going back on the exhaust stroke, for example, during this stroke, especially if the engine is running at high speed, the piston will have a rapid change of direction from a downward stroke to upward stroke, and this will subject the connecting to a tensile strength, a tensile stress. It will be pulling it out. Power will be compressing it, compression, compressive stress, and compression. Once it is done, then it will be followed by the exhaust stroke where we have a tensile stress. The other one is a buckling. High compressive loads can cause the shank to bend, buckling either to this direction or to this direction. Buckling is there. So high compressive loads can sometimes lead to the bending of the connecting rod or buckle if it is not strong enough. And the other force that can act on this is fatigue. The constant cycle for compression and tensile billions of times over an engine life can lead to metal fatigue and failure. So these are some of the forces that are acting on your connecting rod. When you look at materials that are used for constructing connecting rods, usually we have a forged steel. This is the most common material for performance and diesel engines. A hot steel billet is hammered into the shape under immense pressure, aligning the metal's grain structure for superior strength. This type, for example, is made up of forged steel. Sometimes it can be constructed from cast iron. This is used in many standard production engines. This is where molten iron is poured onto a mold. It's cheaper, but not as strong as forged ones, making it unstable for high stress application. And sometimes aluminum is used as a material for making connecting rods. One of the advantages is that it is lightweight. It's very light, which allows for high engine speed, but its fatigue and stretches more easily than steel. So it is less common in modern automobiles, but it is still used on motorcycle engines, for example. And the other material used for generating connecting rod material is powdered metal. Modern process where metal powder is compressed in a die and then heated for making it solid. This allows for complex, near net shape design at lower cost and is surprisingly very strong, using in many modern original equipment manufactured engines. And sometimes it is used to be constructed from titanium as well. The ultimate material for extreme racing vehicles, F1 cars, top fuel, incredibly very strong and lightweight, but it is very expensive. So titanium can be used for constructing connecting rod. Now, what are some of the things that can go bad in a connecting rod? Well, when a connecting rod fails, it is often catastrophic for the engine. A situation known as throwing rod will take place. Throwing rod is when connecting rod snaps and thrown out of your engine. The main causes of connecting rod failure is oil starvation. As you can see, there are oil galleries for lubricating. Oil has to be there, and the connecting rod will squirt oil from here to lubricate the cylinder wall. Oil starvation is the number one cause for connecting rod failure. Here it has to be lubricated. There is an oil feed for the small end. There is an oil feed for a big end as well. Now, the number one cause for connecting rod failure is lack of lubrication. Lack of oil pressure causes the rod bearings to overheat. They will get welded to the crankshaft and they will seize, and the crankshaft then rips the bottom part of the connecting rod. This is the number one cause, is oil starvation. Sometimes the other things that can cause connecting rod to fail is over-reviving of your engine. Spinning the engine beyond its designed RPM limit creates excessive tensile force that can literally stretch the connecting rod or pull it apart. So over-reviving can also be deadly to your connecting rod. The other things that can damage connecting rod is when there is a detonation or pre-ignition. Abnormal combustion creates extreme hammer-like pressure spikes, much higher than normal combustion, that can result in bent connecting rod. If there is a problem with the ignition timing, for example, when piston is moving up and there is explosion inside the cylinder acting in opposite direction, that can also result in bending of the connecting rod. And the other cause for connecting rod failure is fatigue. Microscopic crack from the repeated stress cycle that will grow wider and that can cause the rod to fail. So fatigue, stress can also be cause for a connecting rod failure as well. Symptoms are there. Whenever a connecting rod is going bad, there are always symptoms. For example, you might hear rod knock. This is a deep repetitive knocking or tapping sound from the engine that increases with RPM. This is caused by excessive clearance between the rod bearing and the crankshaft journal. If there is excessive gap right in here, you see tapping like so. When the connecting rod is moving up, taps, down, taps. Whenever the connecting rod is changing direction, it will keep on tapping and you will see a deep repetitive knocking sound that is called rod knock. And the other symptom is where you have low oil pressure. If there is excessive gap right in here, oil under pressure will leak. It will leak out from the crankshaft oil gallery. It will leak out, resulting in total oil pressure drop. This is caused by worn out bearings usually. And catastrophic failure, when you hear a loud bang. Loud bang is when you have a broken connecting rod. That is followed by engine seizing. The rod may have broken and punctured the hole inside the engine block. This is known as the thrown rod or windowed block. So these are some of the symptoms of a failing connecting rod. So these are some of the things that you need to know about connecting rods. As you can see, it gets connected here and it should be sufficiently lubricated to allow for smooth operation of the connecting rod. So when we see the function, the connecting rod converts the piston up and down motion into a crankshaft rotational motion. It's a key link between the piston and the crankshaft, and it has to endure massive stress, compressive stress when power stroke, and tensile stress when exhausting, and compression when cylinder compression is taking place, and bending forces. All these different forces are acting on the connecting rod. That is why the profile is designed in such a way that it can handle all these compressive, tensile, and also buckling forces. And it is very critical structural component, and its failure almost always destroys the engine. Once it is broken, this will also damage other engine components. In order to prolong the service life of your connecting rod, make sure it is well lubricated. A well lubricated engine, proper tuning to prevent detonation, and operating within the engine's RPM limits are what keeps the connecting rod intact. So if you want to prolong the service life, always make sure that you are running with the speed limit of your engine, and also make sure that the engine is sufficiently lubricated. The connecting rod is therefore a masterpiece of mechanical engineering. It's a simple looking link, but it's very critical component that is fundamental to converting explosive power into usable motion. That is why you should take care of your connecting rods. Well, dear viewers, that is all we have for you regarding the connecting rod. If you find this video helpful and if you enjoyed what has been presented, please smash the like button. If you are new to this channel, do consider subscribing. Turn on notifications so that you will be the first to get notified whenever we come up with another video. Until then, stay safe.